Welcome to Study Loop.
So here we're given information about a large insulating sheet. So let's just say this large insulating sheet has certain positive charges distributed uniformly across the surface. So the electric field of this type of sheet, which can be derived from Gauss's law, the electric field is equivalent to sigma over 2 epsilon 0. The sigma in this case, if we convert it into SI units, would be 8.00 times 10 to the negative 12 coulombs per meter squared. And epsilon 0 is any fundamental constant that we can easily find in the table. So we're initially given information that we have essentially a small sphere with mass and charge. So the mass is 5.00 times 10 to the negative 7 kilograms. Charge of 7.00 millicoulombs. And we're given information it's going to go from 0.400 meters to 0.100 meters. So initially it has a speed of 0 meters per second, and now we're interested in its final speed. So we have to use energy conservation, so the initial energy is going to be equivalent to the final energy. So there's no kinetic energy initially, so all the energy will be due to the position due to the electric field. So the potential energy due to the electric field would be equivalent to the charge times the voltage, while the charge times the voltage is also equivalent to the charge times the electric field times the distance from the infinite sheet surface. So let's call this distance 1, which would be 0.400 meters. And we're going to have also a potential energy term for distance 2. However, now we also have a kinetic energy term. So now we're interested in finding this speed. So the electric field we can first determine, as well as we already have information about the charge, and we also have information about the mass of the particle. So the charge is 7 millicoulombs. So 7 times 10 to the negative 6 multiplied by the electric field, 8 times 10 to the negative 12 times 2 times 8.854 times 10 to the negative 12. Then multiplied by 0.3, which is the difference of the two distances, multiplied by 2, dividing by the mass. We can find that the speed as a result is equivalent to 1.95 meters per second. And this gives our final answer.